Welcome back to the solving of the first problem in the Euler project using Python. Last time we did the simplest solution. Let us continue from there and see if we can be a little bit smarter about it. So the problem we have to solve is we want to sum all the multiples of 3 or 5. And we want it to be a little bit faster than the previous solution. One observation is that there is a pattern to where the multiples of 3 and 5 are located on the number line. And that pattern is repeated after 15 numbers. So if we figure out how to efficiently handle those 15 numbers, we can use that code over and over again. So let us write down the numbers that form that pattern. 9, 12, 15, and then 18, and so on. And in between we have 0, 5, 10, 15, 20. So let's see if we can figure out a way to be a little bit smarter here. I mean, we could list them, there are not that many. Something like, while I is less than 1,000, then we need to know where in the numbers we are. And numbers. So figure out every number by taking the next of our special numbers, and then we add 15 every time we have to start over. Counter is of numbers. So we got to end the list, and we have iterations, increase iterations by 1, and increase or set counter back to 0. Need to fix the end condition here, I see. Number is this. Number is larger than 1,000, then we're done. Otherwise we increase by number. So, new program. Invalid syntax, while true. Oh, the numbers, which were basically 0, 3, 5, 6, 9, 10, 12, 15. 12. Don't need 0 here. I do need 0, right? Or 15. One of them I need. 0 is a little bit meaningless. Let's do 3 to 15 instead. Can't assign number to operator. What did I succeed with this time? Oh. Plus. Numbers is not defined. Oh, same number. So, this should be faster, maybe, but it's because there are no divisions, and divisions are very slow. But this is Python, so it's actually rather slow from the beginning. And it's a lot of instructions in the loop, which is also bad. So we could try to time it. But I think this will be we can time it by comparing time.time before and after the code is run. The difference will tell us how many seconds the code used. I think this will be too little work for it to actually take any time either way. If anything, it looks like the second version was slower, maybe not. They're all They're basically the same. But let's go to a higher number. Instead of 1,000, let's take 1,000,000. And they're still about the same time. If anything, the second version is slightly slower. It seems I managed to illustrate how it is possible to make things complicated without any positive effect. That is the reason it is crucial to measure the effect of your supposedly smart solutions. But do not get discouraged. In the next episode I will make a new attempt at writing a smarter solution which I think will be more successful. So see you next time.